Good morning, good afternoon, and good evening, and welcome to the webinar brought to you by SBD Automotive and the Automotive Edge Computing Consortium. Today, I'll be talking with Christopher Boberg and Roger Berg about coordinating the connected car and network edge so we don't break the internet. My name is Dusterhoff. I'm with SBD Automotive, and I'll be moderating today's panel. First, before we get started, let's let everybody introduce themselves. Christopher, can we start with you, please?
Absolutely. Christopher Boberg, nice to be here. I'm my daily work is at the Ericsson CTO office and generally working with technology strategies within cloud and IoT, and specifically focusing on the automotive and connected vehicle industry. I'm also the secretary at the board of AECC and part of the founding members of the Automotive Edge Compute Consortium. Nice to be here.
Roger, can we hear a bit about you, please?
Sure. I'm Roger Berg. I'm with Denso Corporation. I work in our North American Research and Development Department, focused mainly on connectivity, automated vehicles, and associated technologies. I've been at Denso for 20 years. Before that, I was with Sony and Motorola, doing mainly cellular handsets. So I've adapted that know-how to the automotive sector. Denso is an automotive supplier, so we were interested in how the mobility community can work better with the telecommunications community, if you will, to facilitate connected vehicles and mobile edge computing.
Fantastic. Thanks, guys. So, in this discussion, we'll work through a few topics that are going to be covered in an upcoming white paper. A few key questions helping us to understand how we can prepare jointly as automotive and telecoms for a data-rich future. So, the basic premise behind this conversation is that today's internet is not ready for tomorrow's connected cars. Future automotive workloads are pushing the performance boundaries of what we can do in networks. It's pushing boundaries at the network edge, and it's pushing them potentially to breaking point. So without changing the way we manage vehicle data, without changing the way data moves across the network, we really are in the situation where the automotive industry could break the internet by 2030. So with all of that as background, we'll look at a few themes here. One, how we can prioritize and distribute workloads and data transfers to smooth out the network demand. The second, what kind of steps do connected vehicle service architects need to consider to ensure national and global scalability? It's all well and good having a great data-rich service, but if we can't scale it to a large market, then it becomes a difficulty. And finally, is there more to enabling global future-rich data services beyond fixing the data capacity pinch points? So if we fix those pinch points, what else do we have to do to make this future of data-rich automotive industry come about? So before we get started on that, though, we'll have a little poll, see what our audience think about this question of which of these will drive the biggest non-critical data volumes? So we know that there are a lot of automotive services that are going to drive data volumes. Some of those are going to be critical, but we picked a few to look at to get an idea of what the room is feeling about some of the non-critical data volumes. Will we see things coming from parked vehicle security cameras, vehicle and component status, sort of a beefed up health report, streaming live data like battery condition? Will we see vehicle software updates driving the data volumes, or driving vehicles uplink the video coming from moving vehicles for a variety and range of live video image processing services, or perhaps crowdsourced mapping? So everybody look at those, see what you think is going to have the biggest influence, what's going to drive that non-critical data volume. So we can just get an idea of who's in the room, what they're worried about, what they think is interesting and exciting, and maybe tailor a bit of the discussion around the use cases you see as most interesting and important. So we've got about half of people have voted. We'll give it another minute or so. When we talk about things like crowdsourced mapping, that's not just where the road is. It also includes what's on the road, traffic, furniture near the road, surface conditions. When we look at driving vehicle video uplink, that has any number of uses for the live image capture. Vehicle software update is still relatively new in its instantiation. We see that across a select number of ECUs across most manufacturers, but going forwards, perhaps throughout the vehicle on a much higher percentage of vehicles. Vehicle and component status, we know that there are governments around the world who are looking at having much more live data coming from vehicles, but also cybersecurity can benefit from that live data. And of course, Sentry Cam, parked vehicle security cameras, it's great in car parks, but it's also quite handy out front of your house and maybe in the streets. All right, we'll give that another few seconds. We've got a reasonable number of people who voted. Okay, we'll close that vote and see how it turned out. So there we go. So as you can see, we've got a little more than a third of respondents. So that's than a quarter of the people on the webinar today are looking at moving vehicles, driving vehicles, video uplink as the key among these use cases for driving non-critical data volumes, followed closely by crowdsourced mapping and vehicle software update. I think that's a pretty good summary of some of the big use cases. Roger, what do you think? Are we missing anything there, or is that a good representation of where you see the non-critical data coming from in at least the next 5 to 7 years?
Yeah, I think it's a good data point, if you will. I do believe that vehicles are being used as mobile sensors, and in the case of video uplink, that is one of the ways in which a vehicle could be a sensor. I think in general, connectivity is becoming more adept at using these kinds of remote sensing capabilities to drive applications. And this is one way I think in which the mobility sector is I don't know, maybe leading the pack in this area.
Fantastic. All right, we'll move into our themes then and see how we catch up with where our audience is. So in terms of coordinating our data flow, we've got a quote here from Krister saying that we see the vehicles as a sensor, as Roger was saying, and that we see big value there as AECC, as an industry, as Ericsson, as all of the different hats you're wearing, Krister. You see big value for endpoints, whether that's business or individual consumers. But equally, we've got this problem that data is like electricity. The world doesn't work when it all flows at once. We've got to find a way to get it out and back, if you like. So with that in mind, we've got coming up more than 30 million vehicles expected to be sold in 2025, 2026 with forward-facing cameras. That's an awful lot of sensor data. And if that were the only sensor that was uploading data, that would be enough in itself. But we know that there are other sensors on the vehicle that are going to be pushing things up. So could you maybe explain more about how the AECC's proofs of concept have looked at ways of coordinating that data flow?
Sure, and I think maybe proof of concept. Before starting with that, I think I would talk a little bit about the AECC in general and the work we are doing, because I think the main work that we have been spending time on is actually to understand how the what we call the bigger network or the global network really can handle the expected amount of data that vehicles will generate. And so everything that we have been doing in AECC when it comes to our advanced white papers, defining basically the different services that we are looking at from AECC perspective. And I think it was interesting to see that video data, maybe not surprised, but it's good to see though, because that's also what we see as yeah, you call it non-critical, and I can agree. It's maybe what we sometimes call relaxed requirements on latency, etc., compared to some of the more critical. But nevertheless, it's a huge amount of data that need to be sent and coordinated. So the technical reports that we have been created describes basically what is needed from the network side in order for these data to be sent and in order to handle the edge compute in the network. So that is really where we started. We started with the problem statement of in 2025, 100 million new vehicles being connected will come to the market, and that will create a huge amount of data. Maybe we're a bit earlier, depending a little bit on what's have happened on the geopolitical scene, if you say so, also with the pandemic, etc. But nevertheless, there will be a huge amount of data coming from these cars. And again, I always emphasize that it's a completely different paradigm from what we saw in internet, so to say, in what we call from an Ericsson perspective, the 4G era. Now in the 5G era, it's a lot about connected machines, etc., and that is very much generating uplink data coming from the vehicle in this case, rather than the opposite. And that is actually not really handled today. So I think the proof of concept for now, it's first of all in a very early stage, and we started this POC hub that you can find on our website. So the intention of this is to showcase really what have we produced, and also what we recommend, and to show how will it work in real life to solve a real problem. That is what the proof of concepts do. So in many cases then to this is it's a problem of a global industry really meeting a local situation or local providers. So that is what we say, that in order for this to work, we need to have this global standard, we need global deployment, because that's the way for the ecosystem and the industry to thrive and really using the networks that we provide. So yeah, the proof of concept then is the way we really demonstrate the current problems and how we solve them. And this can be different kind of POCs. We have a proof of concept coming from our members, as proposals. Could be proof of concept that our working group provides or propose, and then members come up with proposal for how to solve them. And we even work with external members, not AECC members, together with AECC members to create value. So that sort of the basic work. I can talk more about different POCs as well if needed, but yeah.
Now, I think if we can bring you in, Roger, some of the recent POCs have been looking at how data can be stored locally or transmitted to the cloud depending on time sensitivity. As we say, trying to smooth out that data flow that we've been talking about from the polling question and through to here. Can you take us through more some of the specific kinds of problems those are trying to solve, and give the viewers some of the highlights of what they brought to life in terms of understanding the problems better?
Sure. One of the more recent proof of concepts included this video data being uploaded, but on a local basis. So in the use case that was demonstrated, it was about determining the location of unused parking spots by curbside parking spots. So any car that had a dash cam or any kind of a camera that was used for, I don't know, lane keep assist or forward crash avoidance, can be used in another way to locate, if it's appropriately trained, to locate where these parking spots are available. A lot of the wasted fuel in major urban areas comes from people driving around looking for parking spots. And so if we can have a feature such as this, where the location of open parking spots can be broadcast to people who need, you know, an open parking spot in that particular location. It doesn't matter, you know, 2 cities down or 3 blocks away whether there's a parking spot there, but in the certain region where we would store that data, where it's important from a time and a space perspective, we saw results that were very much, what do I say, cost effective, very cost effective in using that time and space utilization, using the edge computing as opposed to sending that data to a cloud that covers a whole region, a city, a country, a state, a province, what have you.
Thank you. It strikes me that if we're looking at cases like that, it really is trying to balance out what data you're sending various distances from the vehicle. You've got your near vehicle data and your more regional or centralized data. I think one of the terms I picked up when I was reading that white paper was opportunistic data transfer, looking to transfer the right data at the right time, the right distance away from the vehicle. Is that something you'd be able to give us a bit more information about?
Shall I take that, Roger?
Sure.
Start with, or you? Yeah, I can start and then you fill in. No, but I think this is one really interesting proof of concept, one of the first that we did, and it's about, as you say, it's part of the technical report, starting to say that data coming from the car, as Roger also said, I mean, it's a sensor with various different type of data requirements, and not all that data is real-time critical, or maybe even of quite various different type of value and needs for speed, so to say, to bring to the cloud or to the edge. So that's the main topic of that proof of concept, to show really that there are mechanisms in that can be brought into the car, that can be brought into the network to what we say categorize or prioritize traffic differently, in order to decide if this needs to be sent now or if you can wait, or, you know, that is the main thing for that case. And I think that is really, really important going forward, that in order to utilize networks and clouds in a better way, that you actually are quite clear on those requirements, so that you can separate from data that has higher requirement and needs, rather than data that is not as critical. And that is also something we talk about in the first white paper, that it's a question also about cost and availability, right? So you need to be able to separate on that. Roger, anything? Yeah, sorry.
Sorry, you mentioned requirements, and Roger, as you talk about this, are you developing requirements through these POCs? Are you proving out specifications? Are you refining them? What's coming out of them that the wider industry can benefit from?
It's a little bit of all of that, Kurt, actually. So our process in AECC, it goes from use case requirements development all the way to the idea of implementation, so that we can show that our designs and that the use case is valid, first of all, and that the design or the architecture for complying with the use case requirements can actually be met in a physical implementation. I think that's important that we do that whole cycle, because oftentimes, you know, we might have draw up a use case and we might draw up some requirements, but the feasibility of those requirements being met and the impact that has on the usability of the use case or the application really bears out when you actually do your demonstration. And a lot of times that demonstration, the results of the testing or the implementation or the demonstration really come back to the original use case and further refine the requirements or further refine the implementation or the architecture used to comply with those requirements from the real world data. So I think that is a very valuable cycle in making our use cases, our business proposals, our applications much more appealing from a business and a technical perspective when we can update everything from the use case definition to those requirements to the implementation or the architecture and then the implementation to show that these are really valuable assets for the industry in that we can show valuable use cases and solutions that actually meet the requirements of those use cases.
Cool. And I think one of the virtues of some of these is bringing together both the generator and consumer of that data and its main pathways. And I know that there are some cloud providers also in the group that, so you've got that full range of ecosystem represented, which is
for those kinds of applications, it's not one company can't do all of it, or even one industry can't do all of it. So that's why I think this kind of community collaboration that we have in AECC is really valuable in proving that, number one, there are useful applications and useful use cases, useful user stories. They are commercially viable when we show the demonstration, and then we can use that as examples for how the industry can collaborate to actually build new uses for either networks or the vehicles or the transportation or mobility system in and of itself or as a whole.
Thank you. So we've got this idea that we're understanding that we need to manage our data flow and coordinate automotive with telecommunications endpoints with infrastructure. So if we've got that moving, as you said, Christopher, we haven't gotten yet to the state of hundreds of millions of connected vehicles. Quote there from another AECC board member, Saeed Tabet. But we know it's going to happen, and it's not going to happen in the distant future. It's going to happen in the next few years that our global connected vehicle landscape is in the hundreds of millions. So if we've got all these data-rich services like finding parking spaces, like processing video to find out where the bumps in the roads are, the potholes, like mapping road furniture as we go and developing crowdsourced maps, like having global pan-vehicle software updates. That's a lot of data that's processed locally, and it scales differently to the way we process things centrally, collecting it locally. Can we actually, as a combination of industries, can we scale, or do we have to do something different?
Right. No, I think the paradigm or the concept of what we say the 99-1 or 90% 9 and 1%. We have been talking about that for a while. I think it's a relative figure, of course, but it represents the importance of what you call scaling and balancing data transport and compute, right? So I think the thing is really, before we talk about can we handle all this data that the car generate? Absolutely not. There's no way that you send all that data to central cloud and see what happens, right? So you need to decide really about where to handle what data, what is important where. And I think this is all about edge computing in general, right? Or distributed computing, if you want to say so. I mean, there is a process to decide where do you place the data, for what case, and that will also differ. So it's not like one size fits all, that you always have to put data here. So when we think also that was stated in one of our first white paper that, you know, data need to be where it belongs, and it's either very close to the producer or to the consumer or somewhere in between, depending on who is the consumer, so to say. So we generally say that, you know, data can be offloaded to reduce compute in the car. It can be, and that Rod, you can talk more about that. You know, what limits you have in the car, like buffers or compute tech, etc. But I think the main thing also then, that's one thing, right? You need to compute it in the car, but you can also localize it, what we call in AECC the localized network, right? We talk about that a lot. That basically you manage data for a certain area, for certain collections of car, certain types of car, etc. So basically, first of all, to say that 90% of the data will never leave the car because it's only for the car or it's of no use, and you need to decide that as early as possible. Maybe you cannot decide that. Maybe the car cannot decide that that's only for the car or for that car, or it's not of use. So you need to send data somewhere to decide if that data should be used, and that's what we call the 10% or the 10, number 10 there, and that need to be analyzed as early as possible, and that's what we typically put at the edge, and that data is analyzed and perhaps distributed further to other vehicles or other entities in the network. And that's by the way another concept, the proof of concept that we showed very early at the Mobile World Congress as part of the AECC statement back then. And the 1% of say is the data that is crucial to keep or to use and be stored, what we computed centrally. So generally data shall be filtered as early as possible, and then you need to decide that even if that happens, how do we handle the amount of data? Well, edge computing is one of the natural cases that we have been bringing in, because we saw before we started AECC that you know, edge compute was talked about a lot, but there were no means really for the industry to use it in a consistent way. So if you can do that in a consistent and cost-effective way, there is a lot to save when it comes to transport, compute, etc., in order to handle the data that is needed. So that is one main thing we try to focus on in AECC.
You mentioned a 99-1 concept, so 90% of the data stays in the car, processed in the car, either aggregated or compressed or whatever. In terms of volume, 9% happens, something happens with that data near the vehicle, as you say, in a local network infrastructure, and then 1% goes centrally. Now, I'm pretty sure that's not how a lot of things are happening now, if we take it away from critical data where everything has to be calculated in the car, because you have to be able to ensure that it's driving safely. But if we take that forward at scale, Roger, what does that mean for in-vehicle architecture and components? Do we have to do something different as automotive engineers to make sure that the hardware can cope with the 90% of the data that Chris is saying? Maybe we don't need that to go onto the networks. Maybe we don't, or we certainly don't need it all to go to a centralized cloud, because most of it's not relevant to a global fleet. What's the impact on cars of that sort of concept, and how can we think about that in a way that scales to the future?
Well, the distribution of that compute and storage configuration, I guess, is still a relevant research topic. I think a lot of the needs depend on how the use case is defined. Sometimes you can do all your computing on your vehicle. Sometimes you need, computing that doesn't exist in your vehicle system because it's an older vehicle, or it doesn't have the capacity to compute or store relevant data in order to comply with the requirements of the use case. And so sometimes we have to go off board to get those resources that enable those services on a vehicle with limited compute capability. Now, when we start to talk about safety systems, like advanced safety systems that are becoming more prevalent, in vehicles these days, we start to add a little bit more of that compute power, and therefore those kinds of vehicles that have those architectures that allow for ADAS processing maybe have some capability or some ability to use that processing capability for some of these distributed data use cases that we're talking about, but not all the time. And so that's when we have to think about where that compute and storage is actually located and how it's more cost effective. If you put all kinds of compute power just in every vehicle, then the cost is big for the vehicle manufacturer. If you can offload some of that computer data storage to the edge or the infrastructure, or some of that data that's necessary, or that compute power that's necessary for a particular region or a point in space and time, then that's more cost effective to be distributed in the infrastructure rather than in every single vehicle. So it really depends on the requirements of the use case at hand and where that compute and storage is optimized from a cost and a usage perspective.
Okay, so it seems to me it's kind of analogous to the problem telematics faced maybe 7-8 years ago, where every byte seemed to cost an absolute bomb to an OEM. And so that sort of opportunistic data transfer then was, well, we'll aggregate all of the data we would have sent over the course of the day and maybe send it every other day. And so it required a little bit of a memory boost in the car, some reasonable processing. Things happened after shutdown, so we had longer shutdown times for maybe an extra 3 minutes, trying to package stuff up and deal with it away from the drive cycle, for example. Is it safe to say that this 99.1 concept actually goes into the car as well, where we're looking at, there's an awful lot of data in the future vehicle with its GPUs, with sensor data from all around the car, full 360-degree camera, LiDAR, radar, sonar, in-vehicle cameras, and all the good stuff that we're putting into cars for some really cool use cases. Is it safe to say that that sort of 99.1 concept also applies in car, that 90% of the data we're probably just going to use once and bin, 9%, 10% is that sort of, this may be of benefit outside this ECU to other pieces of the car, and then that little tiny nugget is actually worth sending up into the edge or the cloud for consumption away from the vehicle? Or do we have an analogous situation in the car of trying to do our own scaling before we even start to look outside the car, do you think?
To a certain extent, and like I said, it depends really on the use case that you're talking about. Some use case might follow that 99.1% partitioning. Another use case might need 50, 40, 10, or another use case might need 20, 80. It really depends on the computation and storage requirements to deliver a certain use case.
Cool. Do you have any thoughts on that, Christopher, before I jump on to the next poll? And yes, we do have some questions coming in. We will have a Q&A time at the end.
I mean, Roger is the expert on the in-car, of course, so I will not question that. But I think you're right in general. I think it's very use case specific. As I said from the beginning, that 99.1 is just the thinking, right? That you should try to filter out as much data as possible when you can. If you don't have the mechanism, to do the filtering at the edge, I mean, you need to send it to the central cloud, and that will be costly and ineffective. And if you cannot put the mechanism, what we call analytics at the edge, for instance, to actually analyze and maybe steer what data in more real time, what the car shall send. I mean, you should avoid sending duplicates, but the car doesn't know if it's a duplicate or not. If you can steer that to happen, you can save a lot. So I think it's completely right, but it depends what type of data it is. So yes.
Yeah. Thank you. So before we crack on to the third topic, wake everybody up. Let's ask you another question. Let's assume that we get our data scaling and our data transfer coordinated, and that we've got a good idea as two working together industries about how to have a smoother data path from vehicle through the network into the local and regional and global places it wants to go. So let's assuming that we get there, what's the next big hurdle to the automotive and telecoms industries providing services supported at the network edge? Services where the network edge is supporting, it's a key support piece to those services. What are some of the big hurdles that we've got to fix, otherwise known as what's next on the list after we get all of that right? Are we looking at service uniformity across the market, being able to offer the same service in every city, every major city, or every state or region of a country, every country in Europe, for example? Are we looking at sorting out the service uniformity across segments so that we can offer the same sort of segments, services in A and B and C and G segment vehicles? Maybe some using local networks, some using in-vehicle compute. Are we looking at an automated adaptive data flow versus processing versus transmission cost calculation so that we know fairly easily when we need to be doing something in the car at the edge, maybe somewhere more regional or centrally, and doing that, adapting automatically to when we need to send or store data to best smooth out that path? Or are we looking maybe at finding the right use cases for fleet applications, finding the things that are not just looking at consumer interest, but looking at those big OEM or logistics fleets that run vehicles around our major markets, major rental companies, major delivery companies? Where do we think we need to head next? We've got a few people have voted. We'll give it another minute for anybody else who's still keeping track of where we are, and give them a chance to vote. And I think before I'll close that vote in just another 10 seconds or so. And then before I open it up to show the results, I'm going to ask our panelists the same question. If these are your four, still have a few people voting. Before I put it to you, Roger, you and Christer can think about this and see which one you think the room is going to go with, rather than which one you feel. Let's see if you can guess what everybody else is saying, and we'll close that now. Oh, wait, we've had a whole load of people wake up, and we'll give them another 5 seconds. All right, we'll give that a close. So, Christer, where do you think the room landed?
Yeah, I was thinking myself about them, and I think all of them are important.
Right.
So I would say,
Right.
I would say it's very similar on all of them. I think that yeah, that's tricky. I think maybe that the one of the two last could be what the crowd is thinking about. I'm more into the two first, but I think maybe that attendees are thinking about the two last ones, perhaps. Yeah.
Okay. What do you think, Roger? Where do you think the room might have landed?
It's hard for me to say. I think
All
I
right.
agree with Christer that all of them are important and all of them are challenges at the present time. I think one thing that's valuable is that I think as we move through 5G advanced and into 6G, a lot of the different market segments are all after the same thing, and I think that's going to be beneficial for from a commercial perspective as well as from a just service availability perspective. But I think you're gonna need as a cellular service provider or a connectivity provider or a transportation mobility provider, you're going to need to have the same characteristics and same capabilities, no matter where you are or no matter who's your target market. And so I think that will play a big role in achieving some of these objectives and meeting some of the requirements on a wide range of use cases, not just for mobility, but for other vertical markets where connectivity is important.
All righty. Thank you. Let's see where the room landed then. Right. I think we have a lot of network people and people who are interested in cost on today. So half of the respondents are looking at adaptive data flow processing and transmission cost balancing. So, trying to get that balance to happen automatically, adapting to what else is going on in the network. And it's a fascinating problem. One that we could spend hours, I'm sure, talking about and enjoying trying to find good ways of making that happen. And then we've got the other three fairly uniform, looking at service uniformity across the market and across segments. And then if we think of it as a segment of its own, finding the right use cases for fleet applications. As you say, Krista, they're all big hurdles ahead of us. It's a case of trying to figure out which ones people are most concerned about and which ones they think are in their way of getting where they need to on their own development, and maybe where they're able to contribute to the story. And that
maybe just happy to see that number 3. It was interesting because then you see the value of what we talked about, also our first proof of concept, to have differentiation in managing the traffic flow. So happy to see that.
Absolutely. So in that theme of where to from here, we've got a couple of points that are mildly related, but they impact where we go from here. It's the discussion currently going on in Europe about trying to change the way or increase the number of large companies investing at the outset for telecommunications network. And a point that, well, we've come across as automotive industry for more than a decade now, that nobody really wants to pay for internet infrastructure. And when I say nobody, there's nobody standing up saying, I really want to spend all my money on this. Because we all know it's hard to get your money back. It takes a lot of time. And so if we want to change that from nobody to somebody, we have to come up with some appealing services, some appealing benefits to multiple markets, so that nobody changes to somebody, or in some case, anybody. I'm not going to go into who that should be. The question is more around where do we think we can go to bring those appealing services that actually make it interesting for somebody at the end point. We all know that the end point in the food chain always ends up paying for whatever service. How do we make that payment appealing to people? What kinds of things do you think we can be offering? Roger, I'll throw that one at you first and
thanks.
Let you run with it for a bit.
I kind of tried to touch on this concept a little bit previously, that I think there's multiple sectors that are actually trying to address user requirements that are similar for different vertical markets or different use cases. And I think that will drive the investment in that, in order to meet some of these use case requirements, the investment will be necessary, but it will be useful in more than one sector. It's not like mobility will fund the building of 5G advanced infrastructure, or that the metaverse will be the only one contributing to the needs of the new connectivity requirements. I think, or medical, or whatever industry you wanted to start to talk about. I think that what I'm seeing is that they're all driving towards many of the same requirements, and that will prove to be a better investment for the equipment manufacturers and the cellular or connectivity service suppliers.
What do you think we need to be doing, Christer, to increase the number of companies, industries, people who are willing to help foot the bill for the infrastructure that's going to deliver these services? Where do you think, let's try to keep it to connected automotive. Where do you think you can see, from your experience today in AECC, some benefits coming out that might be appealing?
Yeah, and looking at this question and thinking about it, it's a very, very advanced question if you look at it from a society perspective, right? Because this is all about the future internet and how it will look like and who is paying for it. And as we say, there's nothing as a free lunch, right? There's someone need to pay it, and in the end, it's always the what we call the end user, the consumer, that is using the service that is paying for it. But it could be in different ways. And I think you're absolutely right that when we look at the next future services, there will be a need for what we call a network densification, network build out, etc. And maybe that's even more apparent when you look at the mobility industry or the connected vehicle industry, because it's moving around not only in populated areas. So there's a different paradigm of that. But I think coming back to more of services, first of all, I think we should go back a bit to what we stated before, what Roger and we were talking about, that the vehicle is this fantastic sensor, right? It's what we can call a crowdsourced advanced sensor. I mean, a smartphone is also a sensor, but it has huge limitations compared to what you have in the car. So I think there will be a lot of data. I mean, data in general is the key for this, and I think that having data generated, using that for different kind of purposes, that will be absolutely needed. Exactly what for, I cannot tell, and that's not my business, so to say. But from if you say network vendor from Ericsson perspective, we absolutely see that densification of networks is necessary. I think though that the biggest paradigm happening now is obviously XR and metaverse in general, right? And that it's interesting because if you look at those use cases, very similar to what the AECC started to talk about 2017 for the automotive industry. So I absolutely believe that the things that will be paid for in one or another way by different actors will relate to the XR space, let's say. And that will be broader and bigger than the automotive industry. But I also believe that automotive industry and connected vehicle will be a big part of that paradigm for sure.
So in many ways, the vehicle is providing non-specific data. If I keep it away from what people often think about data privacy, about my credit card details, all of that, it's providing data about the environment around it, which effectively is feeding the ability of a digital twin of a city to always have live data. It's feeding the representation of what's going on in a city, so that we've got a digital representation of traffic flows, of traffic density, of what types of vehicles on the road. So are we looking at heavy logistics usage at this time of day, trash collection at that time of day, passenger car traffic at a different time of day, and building up that environmental context picture around the vehicles, using the car as that sensor. And so consumers of that kind of data, whether it's for creating a game about what's going on live in New York, or actually providing some sort of useful digital service based on that data, that's where you're seeing the sort of confluence between the mass data flows for these non-critical types of features we were talking about and the data consumption for additional services.
I would say so, and that's why I say it also is that is where AECC is focusing. That's why we started AECC, Automotive Edge Compute. We were even discussing when we started it to call it something else, like Automotive Big Data. So it's all about how we handle that and categorize different importance of that data. But I do believe that that's where the biggest sort of new type of services will reside. Then obviously there will be a lot of other things coming from the automotive side, but I let the experts in the connected vehicle decide what services they can get paid for, if I put it like that.
Yep. Fair enough. We've got about 10 minutes going. I'm do a quick wrap up of where we've been and open up the floor to questions. We've got a few coming, and hopefully a few more will join the queue that I can work through. So essentially, we started off looking at, can we scale all of the services and data flows that we know we want to with the vehicle as a sensor, with the way the internet is built today, which is downlink heavy? And the answer is no. We need to do something different. We need to do more in or near the car rather than just pump everything off to a centralized cloud, because the internet, if we do that, will break. We moved into a few different areas around what that means in terms of actually making that data smoothing and data flow control happen, where things happen, making sure that processing and data flow are relevant to the places they go in terms of distance from the car. And then you brought that back, Krista, into, and once we've got all of that, the right data, the most relevant data that's not just relevant to the car itself, that's relevant to an outside world of some type, that's really where we're expecting to see the interest from the outside world in what the automotive, the connected automotive industry is providing in terms of that data for wider consumption. So it's a nice little neat package. I'll be honest, I wasn't sure where we'd end up from this question, so it's nice that it's rounded back to the start. With that in mind, I'll start working through the questions. The first one is, how can the industry handle creating a standard set of software components, data definitions, interfaces at the edge, while also coping with the different edge implementations, different and fragments of privacy regulations across different countries and regions? What's the AECC's position and role in helping its contributors and members navigate, well, what can only be described as a spider web there of different requirements and industrial approaches?
Yeah, do you want to start, Roger, maybe?
I'll take a swipe at it. I think that's really one of the reasons why AECC was created. It's to get people who have these different sets of expertise together to see what the state of the industry is and what the capabilities will be in the future, in the near future, and show that they can be implemented and demonstrated now to sort of set the stage for commercial deployments eventually. As I mentioned before, I don't think there's any one company or even one industry that could satisfy all the needs of what the community like AECC provides, and sets up our kind of a vision of our future in what kind of use cases will be addressed, or what we will focus on, how the architecture will be put together to give a flexible array or a flexible configuration of compute and communication in order to solve some of the use case requirements that we talked about.
Yeah, and maybe just adding, I completely agree. Of course, I think that also a lot of the work actually has not been to find new things. It has to be to point to things that exist and standards that exist, and say that, and the plethora of things that has been standardized, this is the best, the blueprint, so to say, for this use case to work in the best way. This is what auto manufacturers, network vendors, telecom operators, cloud and edge providers, application providers should apply and comply to. And that's sort of the main reason. But yes, it's a good question. I think that there are pieces that are easier to standardize, that have more of what we call a multi-vendor, multi-actor approach than others in this space, obviously. And but we are trying as much as possible to work in what we call an open ecosystem, open and multi-vendor fashion, so to say that anyone that want to comply should and can follow these principles. and then it's up to I think the industry in each segment to do that, right?
Thank you. We've got a little bit more interested in hearing about one or two of the proofs of concept. And we talked about the one for finding parking spaces on the road. Are there any others that you would want to highlight that show real world examples of computing as near the vehicle as possible and only as near the vehicle as possible to understand that that processing data not just locally but at the right time of day, in the right sequence for smoothing data? I don't know if you wanted to pick up with that one, Roger.
Yeah, I think Christopher mentioned this about opportunistic data transfer, whereas the age or the latency of the data is not so critical to a use case or to a particular event in a particular point in time and space, that we can use capacity that's not totally utilized like overnight, or I think the use case talked about sending map data, 3D 3D map data over the non-congested network at nighttime, as opposed to having it there during travel hours. I think that is one example of conceptually looking at those data and data storage and data computation resources that are available to optimize their use depending on the way the network is configured and your use case, the particular needs of your use case.
Okay. Speaking of scheduling, questions come through. How can we schedule resources at the edge when we're driving at pace, which means we may be handing over every few seconds, every few minutes? How does that get optimized? Maybe, Chris, you can give us a few pointers on how that works.
Yeah, and we have done a proof of concept. It's actually not on the POC hub, I think, but we showed it in MWC, I don't remember, before pandemic, where we actually, I think it was, yeah, I don't exactly remember the company names, but it was actually showing exactly that. How do you handle mobility in a case where a car drives at a certain speed over multiple, what you call packet gateways in the network and edge instances? And that POC showed two things from Edge white paper or technical report. It's what we call the edge data offloading and the what was the other name, Roger, of the function? Edge data offloading and edge site selection. I think it's like how do you find the user plane or the packet gateway or UPF, and how do you hand over to the right instance of the edge instance for the application, because it will be different depending on the place. So that is what's shown there. I think that can be found maybe on the POC or at the internet. So that's one of the cases we actually have in the TR and in the POC.
Right. Cool. We've got about 30 seconds to go, so I'm going to ask you a quick question and ask for a simple yes, no. We have a question: do you see a lot of these POCs can be done using a cell phone as an edge device rather than a network infrastructure device? So you've got a cell phone in the car, it's got a lot of compute. Could you see that as an extra compute node to help out on some of these use cases?
Yes.
Yes, cloud everywhere.
Fantastic. Yes. Excellent. Thank you very much for your time. Thank you everyone who stayed on to listen through the entire webinar. I hope you've gotten a lot out of it. I certainly have. The AECC will be following up with a link to the white paper to download, I believe, early next week. So enjoy your weekends when they come, and thank you everyone for joining.
Thank you, Kurt. Thank you, Christopher.
Thank you, Roger. Thank you, Kurt. Thank you, everyone. Bye-bye.
Bye.
Bye.